I will be doing problem 7/15. First, you draw the bited diagram for it, and then you solve for your sum of forces in the x and y direction. The sum of forces in the x direction will equal ax equals 0, since ax is the only force in the x direction. And then sum of forces in the y is going to equal 0, to where sum of forces in the y are ay minus 6 minus 12 kilonewtons plus b. And then we need to find what b is, so what we'll do, we'll take our sum of forces, the moment at a equals 0, which will then equal 0, which equals negative 6 times 2 minus 12 times 4 plus b times 6. And we'll find that b equals negative 60 divided by 6, which equals 10 kilonewtons. Then we'll find that what our ay is from the original equation, where ay equals 8 kilonewtons. Now that we have our sum of forces, our basic numbers, we can draw graphs to where we can find each cut and shear force and moment. We use our cuts at each of these points of 2 meters each, so this will be like our point C and our point D. So we know that this is 2 meters, this is 2 meters, and this is 2 meters. We know at the very beginning we'll have 8 kilonewtons because of ay, and then we'll find the sum of forces at the first 2 meters, Fy equals 0, where it's going to be ay minus 6, because we'll have 6 out at 2, minus that shear force at that moment, which will be V equals 2 kilonewtons. So we'll know we'll be down here at 2 kilonewtons. And we'll know this will be a straight line because nothing interferes with it, and it will go straight down to here. And we know from here to D, nothing interferes with it, so it will be a straight line all the way to here. And now we find total force of y equals 0, where 0 equals ay minus 6 minus 12 this time, minus the shear force at 4 meters. And we'll find that V equals negative 10 kilonewtons. Go all the way down to negative 10 kilonewtons. Nothing messes with it, and then at the very end, we hit the very end of the body diagram, so we go straight back to 0. This will be point A, point B, C, and D. This is our shear force graph. And then we'll make our graph for the bending moment, where we'll start out at 0 because our moment at A equals 0. Have it. This is all the way at the end, B, C, and D. Our first cut at 2 meters, we'll have to where the moment cut minus 8, which is ay, times 2 its distance equals 0. we'll find that the cut equals 16 kilonewtons times meters. So we'll go up here, it's gonna be 16. And then we'll go to 4 meters. Well, it goes 0, where I'm at the cut. Minus 8, 4 meters now, since it's further away, plus 6 times 2, since that's in the other direction, making it go counterclockwise. And this will equal 0, to where the moment at the cut will equal 20 kilonewtons times meters. So here will be 20 kilonewtons. And knowing that at B, there's no other force that affect it, and knowing the full body diagram where the moment at A equals 0, we know that at B, it's going to equal 0. And that is the shear force and bending moment diagram for this problem.